So we can work with a couple different really helpful models to simplify adding with fractions and decimals. The two models we're going to talk about are the money model and the clock model. And these come up in this calendar grid here. So these pieces are a little bit small on the screen, but let's think about this for a second. We talked about this in class. How many squares could there be in this grid? And one of the things we want to make note of is that that grid is a square. So the only possibilities are that this is some kind of square number. We might be able to just at a glance recognize that this is 5 across. So this is 25. 25. And there's a little coin in here, and this is actually a quarter. And so this little card is saying a quarter plus a quarter. And so what we would do for that is we would notate that. So we could write it a quarter plus a quarter, like 25 cents plus 25 cents is 50 cents. We might be thinking 25 times 2 is 50, and that's okay to think about. We could also think 25 cents times 2 is 50 cents. But if we look at how this is really represented, it's showing addition, not multiplication. So I think I want to try to stay as close to what the picture's saying with the mathematical expression. The next day, we see a completely different model. Actually, we're seeing the clock model here. And so we kind of want to figure out, well, what's going on with these? And how do we even use this? Well, in this case, I'll go back to the money. In this case, the whole is the dollar, right? So each fraction is part of that whole. In this case, the whole is the clock, the circle. And the circle is broken into 12 parts or 60 parts. And so here we can see, well, in either case, right, this is a quarter of the circle. And so you can see in the blue circle that I made here, if we just chop something into 4 equal pieces, this is a quarter. So we're really talking about the same exact fractional picture here, is a quarter plus a quarter. But we can also talk about this using the clock. So we can say this one is 3/12 plus 3/12. 3 somethings plus 3 of the same somethings is 6 of those somethings. So we've got 3/12 and 3/12 is 6/12. You could equally say it is 15/60ths plus 15/60ths, and that's 30/60ths, or 1/2. The next one we get into is a rectangle that's not a square, and this one looks like it's 5 by 2 groups of 5, so 5 by 10. This is a 50-cent piece. And so here we have 50 cents plus 50 cents, and we get our dollar. And then the clock does the same thing, half a clock plus half a clock. The reason why we're working with clocks and money are that they're very familiar and useful. And I want to bring this back to a topic we talked about earlier, which is factors, right? So the reason why 60 is such a useful thing to use with fractions is that 60 has so many factors. Just look at this list, and I actually started this out, and then I was like, well, let me just do the prime factorization of 60, which is 2 times 3, 6, times 2 times 5, 10. And then you can just kind of pull out all the factors. You can say, oh, there's a 2, oh, there's a 3, there's 2 2s, so there's a 4, there's a 5, there's a 2 and a 3, so a 6. But look at this list, 1, 2, 3, 4, 5, 6. The first 6 numbers are all factors. It's pretty special. And then you've got 10, 12. So you can do a lot with any fraction that has one of these as a denominator. And money has some of the same ones. It also has 25. And it's also just a little bit more familiar and matches our decimal system, which the clock doesn't because it's base 12 or base 60. So here we're just tracking these expressions, and we want to be able to write this as a decimal and as a fraction. And the other really important thing too is to be able to take a fraction problem that is without a context and put it into the context of time or money, and then get that answer. So like say we got 30 minutes, and then put that back into the context that is not time. So to take it out of the clock and say, oh, well, 30 minutes really means 30/60ths. And so that's how we're just using the clock as a concrete context to solve a different problem. So we get into like, let me get over to 5 and 6 if I can. Where are those guys? Okay, so 5 is a dime plus a dime. And I think the picture of that was a little abstract. They just put the dimes in. So we got 10 cents, which is 1/10, 10 hundredths, or 1/10 is a fraction. So it's 0.10, 1/10 plus 0.10 or 1/10 is 0.20 or 20 cents. Or as a fraction, 1/10 plus 1/10 is 2/10. We can simplify, right? And simplification of fractions could be also called reducing. It means taking out common factors from the numerator and the denominator. So in the case of 2/10, right, their greatest common factor is 2. So we could divide both the numerator and the denominator by 2. This is not, strictly speaking, always helpful or necessary. So 2/10 here kind of preserves that we're dealing with the quantity 2 and that they are tenths. So I don't always need simplification if it's a useful denominator. We're also going to see the same problem come up in the clock. And so let me come back to that. And this one here is interesting. So 1/10 and 1/10, looking at the clock, is funny. It goes over to 5 minutes and then one more, 6 minutes, which makes sense, right? Because 6 is 1/10 of 60. It's just maybe not the most natural thing to work with on a clock. But 1/10 plus 1/10, yes. 6/60ths plus 6/60ths is 12/60ths. And here, just to understand 12/60ths, right, we might want to simplify that, right? And it does simplify down to 1/5. We don't really talk about 1/5 of an hour, so we might maybe just leave it, 12 minutes or 12/60ths. And this is just kind of an introduction of how we're working with clocks and money models to do fractions.